Hey guys, this is going to be the video key for the Unit 1, Part 1 test review for you guys at home in case you were having questions, you wanted to watch this again. You don't have to watch this whole video, all right, you can just kind of fast forward and skip around to the questions you need, but I am going to go over every single question and how to do them. So question 1, all right, domain and range when given points. All right, that's when you use the squiggly brackets and you just kind of list out the numbers. So the domain values will be the x values, which are the numbers that come first in the coordinate. The range values are the y values, which come second. And you don't need to put 4 twice. All right, you can just put 4 once. Is this a function? All the inputs are different, so yes, it is a function. Number 2, same thing. All right, we've got 1, -2. We don't need to put 1 twice. -3. Range 3, 4, 5, 10. Is this a function? No, because 1, all right, has an output of 3 and 5. So 1 has 2 different outputs, which means this is not a function. If we have points on a graph, same thing, all right. We're going to list them out, and you kind of just look down, all right? So this would be at 1, 2, 3, so that'd be at -4. The next one would be at -3. This one would be at 1. These ones will be at 1, 2, 3, 4, 5. Now notice there's 2 here, so I already know it's not going to be a function. For range, we do the same thing, but again, we're looking at the y values. So down here, that's 1, 2, 3, that's -4, -2 for this one. That one's at 1, this one's at 2, and that one's at 3. So that's if you have points on a graph, but they are not connected by a line. If they are connected by a line, remember that's when squiggly brackets go out the window and we use interval notation. So we look at the far left point, that's at -5. We look at the far right point, that's at 3. So our domain is -5 to 3. Domain is left to right. Range is bottom to top. So we look down here. That's the lowest point on the graph. That's at -1, -2, -3, -4, -5. That's at -6. Highest point on the graph, that's at 1, 2, 3, 4. So the range is -6 to 4. And this function passes the vertical line test. All right, so it is a function. Number 5, all right, here we have arrows, okay, so this is going to be a little bit different, all right. We notice we have arrows on left and we have arrows on right. So this time, that's going to be -infinity to +infinity, all right, when you have arrows on both sides. For range, though, we don't have an arrow on the bottom. Looks like the range starts at -3, but then we do have arrows on top, so that'll be going to infinity. And this is a function, all right, it's a v. That's the absolute value function. Number 7, domain. So we have far right and far left. Okay, so on far left we see a point. That point is at -3. On far right we see an arrow, so that's infinity. Range are actually the same 2 points. All right, our lowest point, its y value is 0. And then on top we have an arrow, so that's going to infinity. And is this a function? Again, yes, this is the square root function. So that's domain and range, all right, a couple different examples. Next, we have function notation, all right. Function notation, we are inputting values. So this says g, so we are inputting into the g equation. So you got to be careful about making sure you have the right letters matched up. All right, so g of -5, so we plug in -5. And for x, now again, look how important it is to use, I want this erase. Okay, sorry. Use parentheses because see here we have 2 negatives, that's going to become a positive, right? negative 5 squared, that's positive 25, plus 5, so this answer will be 30. B, we're plugging in negative 3, all right? So again, this time we're going into the F equation. We got to match our letters up. So we have F and F right there. So we have negative 3 halves times negative 3 plus a half. A negative times a negative is a positive, and then we multiply straight across, so 3 times 3 is 9, so that's 9 halves plus 1 half. These are already like terms, or sorry, they already have a common denominator, actually, so we can just add straight across. That's 10 over 2, which simplifies to 5. So if you guys can simplify, you should. H, we're going to be plugging in 2. All right, so we've got 4 times 2 plus 1 over 2 times 2 minus 3. 4 times 2, that's 8. 2 times 2, that's 4. So we have 8 plus 1, that's 9, over 4 minus 1, or sorry, 4 minus 3, which is 1. 9 divided by 1 is 9. For the next one, all right, this time we are going to be setting these equations actually equal to 38, because now we're being told that 38 is the output of F. So we're going to create an equation that we will solve. So we've got 38 equals negative 3 halves x plus a half. All right. So we need to minus a half on both sides. 38 minus a half, that's 37.5 equals negative 3 halves x. Now we can solve this a couple of different ways from here. One way to solve it, though, would just be multiplying by the reciprocal, which would be negative 2 over 3. So if we do that, sorry, I'm trying to type this into my calculator, times 2 divided by 3. And we actually get an answer here of negative 25. All right, so our input would be negative 25, because that cancels, so we just have x equals 37.5 times negative 2/3. For h, we do the same thing, all right? We're going to take our equation, set it equal to 5, because it's telling us 5 is the output. So we've got 4x plus 1 over 2x minus 3 equals 5. So in order to start solving, we're going to multiply by 2x minus 3 on both sides. That's what's on the bottom of our fraction. So those will cancel out. So we've got 4x plus 1. Distribute here. That gives us 10x minus 15. We get the x's on the same side, so we'll subtract by 4x on both sides. 1 equals 6x minus 15. Add 15 over, that makes 16 equals 6x divided by 6. So x equals 16 over 6, which if we divide both those numbers by 2, that would be 8/3. And that is correct. So that's how you would do the function notation problems with equations. We can also look at a graph, okay? So if this tells us f of 3, that means our input is 3, right? Which means our x value is 3. So if we look at the x value of 3, okay, we cross the graph at this point. If we look over, all right, that's negative 1. So f of 3 is negative 1. We can do the same thing for f of 7, all right? And that actually crosses right there at 7, okay? So that would have a y value of 0. Now for this one, f of x equals -2. Now we know the output is -2. All right, we want to try and find the input. So the output means the y value is -2. And if we look over, all right, we actually have two values here. The first one looks like it has an x value of about 3.5. So we could have x equals 3.5. We also could have, all right, x equals 5. So we could actually have two answers for that problem. Transformations, okay? We want to do the transformation here. Negative x plus 3, all right? So what are these transformations? So we have an a value of -1, all right? That means we're going to have a reflection. We're also going to have a h value of +3, right? So that means that h is actually -3, which means we are moving to the left by 3. So we're going to move everything to the left 3 and then flip it over the x-axis. So that'd be 1, 2, 3, and then flip it over the x-axis. So it's up by 1.5, so it's going to be down by 1.5. This one is actually on the x-axis, so that one's not going to change. It's going to stay there. This one right here, 1, 2, 3. Now it's down 2, so it's going to flip to being up 2. This point, 1, 2, 3. So this one's actually down 4, so it's going to move to being up 4. This one's at the same level, so 1, 2, 3. It's also going to be up 4. And so once you've got all your points, now we can just connect our points. And we see that we have our new function, all right, that has been flipped upside down and moved to the left 3. So now we want to do the domain and range of the new function. So domain, farthest left point, that's at -5. Farthest right point, that looks to be at 2. Range is bottom to top. So the lowest point is about -1.5. And then the highest point looks like it's at 4. So that'd be -1.5 to 4. Last thing we are going to do some transformations, okay? Now, you guys can use Desmos to help you do this, and I'm going to show you how to use Desmos on the first one, okay? When we're listing out our transformations, though, we have two transformations here. All right, we have an h value of -3. That means we're going right 3. Then we have a k value of -4, so we're going down 4. Now, let's say you don't know how to graph this, right? Well, we can pull this open, and you can just type in this equation, right? Y equals absolute value of x minus 3, and then minus 4. So if we look, our graph has actually been moved down to 3, -4, just like we said, right 3 and down 4. So we can count that off, 1, 2, 3, 1, 2, 3, 4. And then we know that our graph is a V shape. We can look and see that. So I'm going to draw my two lines, and there we go. All right. We have our graph. Now, I'm not going to do that every time because I don't need to, and you guys know how to type stuff into Desmos. But if we do domain and range, so domain is left to right, all right. I remember I told you most of these are going to be -infinity to infinity just because they're going to have arrows on both sides. So we're going to put -infinity to infinity. The range is the only thing that changes. So this range is down 4, so we're going to start at -4. That's where its lowest point is. And then on top we have arrows, so we have going to infinity. So that's how you would do that problem. For the next one, all right, we have an x squared, all right, so that's going to be a u. Now, what are our transformations? We have an a value of -1, so that's a reflection. Then we have a k value of -2 on the end, that's down 2. So we have a u, all right, that's being reflected, so it's going to be flipped upside down, and it's going to be starting down 2. So we have a u that is going to be like this, all right? And I'm sure if you typed it in Desmos, it would give you that same thing. Domain and range, so domain, again, we have arrows on both sides, left and right, so that's -infinity to infinity. Now the range here though is different. It's going up and it has actually a highest point. On the bottom we see arrows, so that's -infinity. And then the highest point is at -2. So that's what happens when it gets flipped upside down. Next problem. This is a square root function with an a value of 2, so it's going to be stretched by 2. And it has a +5 inside the square root. That's an h value, so that's going to be left 5. All right, so our, remember for a square root, that's a little curve. So that's going to be starting to the left 5. And for the stretch part, you guys can look at Desmos to look at the actual points, all right? But essentially, just all of the points are going to be doubled, so the next one will be at 2. The point for 4 will be up 4. And then the point over 9 will be up 6. So it'll look like that. So for domain, its farthest left point was at -5 because it moved to the left 5. Then it went off to infinity. The range didn't move up or down at all, so it stays at 0 and goes to infinity. Last one, we have another reflection here, all right? And then we have a +3 on the inside, so that's going to be left 3. Now, this is a cubic function, so remember that's the slide. Again, if you can't remember the shapes, you can look on Desmos. So our middle is going to be to the left 3, and it's flipped upside down, so the points are going to be backwards. It's going to be moving down. And again, you can get these points off Desmos if you want. You can look on a table. Doesn't have to be perfect, so that's our shape right there. And cubics are actually like linear functions. The domain and range are both -infinity to infinity. Because it doesn't turn around or anything, it just goes in opposite directions. We have left and right. We also have bottom and top. So that's going to be both infinities for both domain and range. So this is the review. All right, it's fairly similar to the test. This is all the skills that you guys are going to be using. If you have any questions, make sure you let me know, and have a great day.